You know that feeling of walking down a vibrant city street at night, just completely bathed in the glow of those captivating neon signs? It's iconic, right? Well, today we're going to break down exactly how these glowing tubes of glass actually work. We'll explore the incredible human craftsmanship required to make them and look at how modern technology is totally reshaping the industry.
Think back to the 1920s. When these signs first started illuminating city streets, the public was absolutely captivated. I mean, the sheer brilliance of an invisible gas suddenly becoming this vibrant light, it was something nobody had ever seen before. It felt like absolute magic. People were literally describing the phenomenon as liquid fire. And honestly, they weren't far off.
So, where did this liquid fire come from? Well, the journey actually starts with William Ramsay's Nobel-winning discovery back in 1898, which is when he first extracted pure neon right out of the atmosphere. Pretty wild, right? Then, a few years later, a French engineer named Georges Claude figured out how to apply an electrical discharge to a sealed tube of that gas. He displayed the very first neon lamp in Paris in 1910. Fast forward to 1923, and the technology crossed the Atlantic. A Los Angeles car dealership bought two massive Packard signs, and boom, it sparked an absolute craze across the United States.
But the real magic here, it's all in the physics. See, neon is a noble gas. That means under normal conditions, its atoms are perfectly happy, completely stable and inert. But when you hook up a high-voltage electrical current to the ends of the tube, that massive jolt of energy rips an outer electron right off those atoms. Suddenly, the gas becomes this crazy soup of positively charged ions and free electrons, completing this circuit from one end of the tube to the other. In other words, it turns into plasma.
Inside that sealed glass environment, it is literally pure atomic chaos. These particles are constantly colliding, absorbing energy, and jumping into this highly unstable, excited state. But they can't stay that energized forever, right? So they instantly drop back down to their normal state. And here's the cool part. Every single time they do that, they emit a photon, a tiny particle of light. Multiply that microscopic action by billions of atoms, and you get that continuous, brilliant glow we all know and love.
Now, you might be wondering about the colors. Pure neon strictly gives us that classic, iconic reddish orange. But sign makers actually have an entire palette of noble gases at their disposal. If they fill the tube with argon, for instance, the light turns a bright, piercing blue. Helium? That burns a stark orange, while krypton creates this really beautiful pale lavender or white glow. So it's actually the unique atomic structure of each specific gas that dictates the exact color of the light.
But what if you want colors beyond just those few raw ones? To get a full spectrum, artisans use some really clever tricks. We're talking phosphor coatings, colored glass, and intricate gas mixtures. By coating the inside of the glass tube with specific phosphor powders, they can transform the blue light of argon into vibrant greens, yellows, or even pinks. They can also just use inherently colored glass, like, say, a red glass tube filled with argon, or even mix the gases directly together. This unlocks over 100 different stunning shades. Section 1. The artisanal craft, glass tube bending. You have to understand, creating these pieces isn't something that can just be churned out on a standard assembly line. No way. It requires years of training and a tremendous amount of manual dexterity. The art of tube bending is an intense, frankly perilous process. It starts with a ribbon burner heating the glass to a scorching 1200 degrees Fahrenheit, just so it can be shaped by hand. The artisan lays out a fire-resistant pattern and uses open flames to soften very specific sections of the rigid glass. Then, while it's red-hot and completely pliable, they carefully bend and twist the tube to match the letters or shapes perfectly. Sometimes they even have to use a blow hose to ensure the tube doesn't collapse on itself during a particularly sharp bend. Now, a really vital step here is something called bombarding. This removes impurities to ensure a perfectly clean vacuum environment, which allows the noble gases to shine brightly. Once the glass is shaped and the metal electrodes are attached, the tube is vacuum sealed. The artisan then shoots a massive electrical current right through it. This heats the glass up and literally bakes out any microscopic contaminants. If they skipped this step, the gas would get diluted, and the sign would just sputter, flicker, and ultimately fail.
Section 2. Powering the luminous tubes.
So the glass and the gas,
they're really only half the battle. The electrical engineering is what ensures that liquid fire actually ignites. The long-standing industrial history of gaseous conduction reminds us that these signs are heavily reliant on serious industrial-grade electrical engineering. The physics behind this whole process have been studied by major corporations for decades, all to perfect the exact mathematical ratios needed to keep a sign burning brightly for years, without, completely destroying itself. It's fascinating, really. The glow actually emerges from the inside of the metallic electrode shell, a phenomenon known as the hollow cathode effect. It relies on a special activation coating to liberate those electrons we talked about earlier. Because electricity always takes the path of least resistance, it's actually easier for the current to jump from the inside of the hollow metal tip rather than the outside. Artisans coat that inside with earth alkali oxides to help release the electrons efficiently, and they have to perfectly match the size of the electrode to the power of the sign to prevent it from overheating. It's a really delicate balance.
And here's where things get a bit dangerous. To strike an arc through this gas, transformers have to generate up to 15,000 volts, which makes this beautiful art quite hazardous. A standard wall outlet isn't even close to being enough to ionize neon gas. Luminous tube transformers take standard power, ramp it way up to incredible levels to establish the arc, and then carefully throttle the voltage back down to safely maintain the light. This is exactly why installation and maintenance absolutely require a trained professional. You do not want to mess with 15,000 volts. Section 3. Traditional gas versus modern LED. For over a century, gas-filled glass totally dominated the landscape, but recently, a new challenger has rapidly taken over the market. We're looking at the ultimate clash here, the fragile, high-voltage beauty of traditional gas-filled glass versus the highly customizable, low-voltage RGB LED technology. Look, traditional neon offers this nostalgic, authentic warmth, right? But it's expensive to make and incredibly easy to break. LED neon, on the other hand, mimics that look using highly flexible tubing that just doesn't shatter. Plus, it completely bypasses the need for dangerous noble gases and extreme heat. This shift to LED is a real game changer. LED neon operates at a fraction of the power and uses intelligent chips to change colors dynamically. That makes it a safer and significantly cheaper alternative for modern businesses. By blending red, green, and blue light-emitting diodes, these signs can achieve absolutely any color on the spectrum. They can even be programmed to flash or change color with just a click of a remote control. And because they only need 12 to 24 volts to run, the energy savings are absolutely massive. But hey, never underestimate traditional craftsmanship. While a standard neon sign is built to last about 10,000 hours, get this, one original panel was actually found running continuously for an astonishing 77 years. Yeah, 77 years. Back in 2012, during a restaurant rotation, workers uncovered a gas-filled neon panel hidden completely behind a wall. Because the vacuum seal was absolutely perfect and the transformers were built so robustly back then, that plasma had been actively burning, completely uninterrupted, since the 1930s. Isn't that wild?
So, as we appreciate the science, the safety, and the incredible efficiency of modern LEDs, it really leaves us with this final thought. Traditional neon is liquid fire captured in glass, a literal piece of the cosmos glowing on a city street. Will this breathtaking, handcrafted art form actually survive the LED revolution, or is it destined to fade away? Keep looking up and keep learning.